Hi, so great to be here again, and thanks for inviting me and for the kind introduction. Good to see you all, and I know this is between us and lunch, so hopefully this will be interesting. Anyway, these are exciting times, more exciting than ever, actually. With technology and AI, actually, they're impacting all aspects of lives, and I'm really excited about what we can do with that. Now, in the context of this, we're here to discuss the circular economy and sustainability in the world. And this is obviously a topic that is dear to us. We're actually just published recently the environmental report about various efforts we're doing across the board. And when you think about what needs to be done, it's really cutting through every aspect of the work and the workflow and operations. And you may take a look at that, but anything from looking into the water consumption to how to have our manufacturing of phones with less plastic, and how to encourage people to actually work in a more friendly, environmental-friendly way. But I'm going to talk today mostly about how we're using AI to make a really transformative change on many aspects in a way that is non-linear, in a way that is kind of exponential or singular. So we firmly believe that technology, and specifically AI, has the potential to actually solve problems, unlock societal problems across all areas in a way that actually can lead to a better future for all of us, for people, for planet. And this is true, by the way, for all aspects. I'm going to talk mostly about aspects of environment today, but this is also true for education, for health, for our experience, day-to-day experience, and so forth. So I'm going to give the perspective of Google Research. I'm heading of Google Research, and we're looking into all aspects of how can you drive technology, how can you drive research across anything from foundational machine learning to systems, to quantum, to science, to societal impact, and so forth. And doing it on a planetary scale, on a human scale, on cellular level, and all levels at all. So let me start with a few examples of some of the work that we can do. But before that, why is it so meaningful today to work on research towards solving these problems? So one thing I've been always personally very excited about is what I call the magic cycle of research, which essentially is to look into problems that we want to solve and then understand what needs to be unlocked, what kind of research we need to drive. And this research is what I like to call intentional curiosity. We're, all my fellow scientists, we became scientists because we're curious about stuff. But quite often, when you ask the question in order to solve problems, that's a little more intentional than just intellectual curiosity, which is great as well. But then, once you have a solution, to apply it back to reality, to actually solve the real problems and really impact, that's actually where you have the full circle. And one thing that we're really paying a lot of attention is how to have this full circle. One thing that I've seen is that if early in my career it took sometimes years to have this kind of circle, today, sometimes in a matter of months, we can actually solve a problem and then apply it, and actually then ask the next question and continue the cycle. So let me start with a few examples of how we're using AI in optimizing transportation, which obviously is one of the reasons for a lot of the carbon emission out there. And a few of those examples, for example, a project called Greenlight is where we identified that actually it turns out that a lot of the carbon emission from cars in cities happens in intersections, where just stop-and-go event, which is a little irritating, but it turns out to be actually a huge contributor to carbon. Turns out that by analyzing what's going on in the intersection, using data which is already there, we can actually make some recommendation of changes of schedule, which has pretty significant impact, actually 30% less events of stop and go, which translates into 10% reduction in carbon emission. And this already applies to many millions of cars in many intersections around the world. And when scaled, this can have significant impact. And by the way, no change of infrastructure needed. So that's an example for actually solving a problem in actually a simple observation that, by the way, one of our engineers came up with over dinner conversation at home. Another example is the problem of contrast. In fact, it turns out that a lot of the impact of aviation on carbon, on global warming, is by those tiny contrails behind the airplanes. Turns out that they're actually blocking the radiation going back from Earth, And if you can actually identify better routes that would minimize contrails, this actually has big impact. And this is, again, based on published work, and turns out you can actually reduce 54% contrails with actually minimal changes to the routes. And again, this is work in progress that we're doing in collaboration with American Airlines and others. Of course, there are other ways to actually optimize. We're making big investments in fusion, looking into how to optimize solar panels and so forth. So a lot of opportunities there. One area when we talk about the planet and its impact on our world is the problem of natural disasters. And of course, this makes the news all the time. And the question is, what can we do in order to address those crises? How can we be more resilient to crises, both in terms of responding to them, as well as in terms of preparing for them? So let me give a few examples. It turns out that we can do a lot. We already do a lot, and I think we can do much more on floods, on wildfires, on extreme weather, extreme storms, or earthquakes, and so forth. Let me start with floods. This is actually a video taken in a village in Bihar in India. A flood came overnight, washed through, destroyed a village. A few people actually perished. And I happened to be there just a few days after that, actually watching the aftermath of that. And this was the reason I was there, is because we started looking into the question, can we do something about this natural disaster that has thousands of casualties every year and millions in economic damages? Now, all the experts told me, no, nothing can be done, the prediction is too hard, too many variables. We decided it's worthwhile to explore anyway. In fact, we published a paper in 2018 postulating that with machine learning and cloud technologies and combining machine learning with physical kind of simulations, we could do something at scale. It did take us a few years to actually go through that until last year we published a paper in Nature showing a global hydrologic model that can actually give a good prediction even if you don't have gauges around the world. And the journey that started back in 2017 actually until now, we already have now a system that not only drove the science of hydrology with machine learning and AI, but also built a system that now serves 150 countries, 700 million people, providing predictions up to 7 days in advance, and actually putting it in what we call a flood hub, which essentially you can see the gauges. The red ones are the ones that you need to be careful because that's a danger level. And this is already being used. In fact, we have a pilot with WMO, with a few countries. And just a few weeks ago, we saw this report from UNCHA and the government of Nigeria. Actually, they're using this flood prediction for preparatory anticipation, essentially sending money to people to evacuate before floods hit them. Any dollar that you put before the disaster can actually is worth order of magnitude more the economic value of what you pay in order to deal with the damage afterwards. Plus, of course, you can save lives. So this is an example for that. Another one is about extreme weather, which is, again, a notoriously difficult problem. How do you predict storms? So many variables. And in the past, we used to have the best supercomputers doing that. We do have now machine learning models that can actually have pretty good models of those storms. And we just published actually some of those models recently in what we call Weather Lab. And recently, somebody actually looked into the prediction that can be obtained from that in the Erin hurricanes, showing that this is actually much better than the state of the art that we had before. And this is an ongoing work. So importantly, it's not only about where we are today, it's where we're heading, which is quite important. Let me switch to wildfires, another devastating natural disaster. Actually, my personal interest in crisis response and crisis resilience comes from my own personal experience. This is a picture I actually took with my own phone 15 years ago in one of the most devastating wildfires in Israel. I was there visiting one of our offices, and I didn't find any information, which actually was a trigger to, hey, people turning to Google like I did in order to find helpful information. We should do something about that. Now, this actually became a journey over years to actually provide actionable information in search and in maps at Google, but importantly, to look into how can we actually provide real-time information about wildfires. Over the years, we actually took satellite imagery and we analyzed and we developed models that we can identify the boundaries around wildfires. and we now have them actually updated every hour in over 27 countries. But we also realize there's a limitation because current satellites, you can only see the wildfire when it's relatively big. This is too late for responders to actually take action on that soon enough. So we actually embarked on the ambitious plan, which we called FireSat, where partnering with others, we are actually developing these satellites that the ambition is that once we have 52 satellites in space orbiting the Earth, we're going to actually have coverage of every point on Earth every 20 minutes. And importantly, the resolution of the identification is going to be such that when we're going to have a wildfire at the size of a classroom, say of 5 by 5 meters, we're already going to be able to identify the fire so that we can actually take action. Actually, just a few months ago, we had the first satellite actually going to space on this program, really looking forward to see how this actually goes on. So when we think about crisis resilience and what we can do in all these aspects, and this is really early stages because with the advancements of AI, with all these models that we have, with the advancement of knowledge, and also with the academic community and scientific community actually building on that and driving more research, I'm really optimistic that we can do more about it. In fact, our North Star is that nobody should ever be surprised by a crisis coming their way. And I think we're already making some progress towards that, and I'm quite optimistic that we're going to get into that North Star. In fact, when we think about all these models, we now have models that are pretty good on hydrology, on wildfires, on water understanding, on extreme heat, on weather. We have actually traffic information, we have models of the Earth, we have the lay of the land, and we have other statistical information such as public health. And then we asked ourselves, how can we actually bring them all together and put reasoning layer on top of that with generative AI so that we can start asking more complicated questions that could be of interest, such as find me the relationship between floods and malaria statistically, or can you let me know which clinics remained open after the last hurricane and connect it to other factors. So in order to do that, we're actually building what we call the geospatial reasoning system that brings together a family of models, which we're going to call Google Earth AI, which essentially is going to enable us to ask and respond to such complex questions, which are going to have impact on businesses, on consumers, and of course, for societal impact questions, such as public health. Now, when we think about platforms and about how to accelerate, what I mentioned are certain efforts for us to try and see how can we advance the science, how can we have better predictions of floods, how can we understand the simulations of the weather, or how can we build models that can tell us where the fire is going to start or progress, or models about healthcare. Now, to that end, when you think about the process, the scientific process, the question that we asked ourselves some time ago was, can we actually help accelerate scientific process itself? And to that end, we actually developed what we call the AI co-scientist. It's essentially a system of AI agents that are trying to help out scientists by actually providing the kind of thing that you would have if you'd have a lab. So we have an agent, for example, a researcher is posing a question, and we actually started with biomedical kind of research. And working in collaboration with a few teams in Stanford and Imperial College London and others, we're looking into the following paradigm. A researcher is posing a question, such as what is the reason for these bacteria to be more contagious than others? Or can you find me a hypothesis for drug repurposing in order to take existing drugs and use it for solving other certain diseases? And the AI system actually has agents that are doing the literature search. And the beauty is that AI can actually go through the entire literature. And then it can actually form hypotheses and test them to the extent possible, as long as you don't need a wet lab, even though this certainly in the future I envision that it's going to do help with some of the experiments. And importantly, then rank it and bring better researchers. So this is the paradigm of asking ourselves, how can we help scientists actually explore the scientific discovery itself? And in fact, we already have a few encouraging results. In fact, some of the early work that we already published in a few papers, for example, is a new target a new target for liver fibrosis, drug repurposing for AML, and in fact, the question of hypothesis for a reason why certain bacteria is more contagious. It's a kind of question that was asked by researchers in Imperial College for a decade. They came up with a hypothesis, they did not publish it, and then they worked with a system to actually test and see what kind of hypothesis it can come with. It came in just a couple of days with the same hypothesis. I should add a disclaimer, by the time that the AI system worked, there was, even though the actual result of the researchers was not yet public, there was a lot of new publications out there in the literature that was already taken into account. But this was an example for what can be achieved, and now we have teams actually working with many others. For example, looking into getting new insights into ALS, which is, as we know, a notoriously difficult problem with very little understanding. And the hope is that with AI system, we can actually accelerate much of that. In fact, another approach to actually accelerate scientific discovery is work that we just put a paper up last night, so your first audience to hear about it, which essentially is a system, an AI system to help scientists write expert-level empirical software. So as part of the scientific process, what you do, you want to develop models, you want to try them, you want to write code that is going to test those models on particular cases. That's actually one of the aspects of scientific discovery and data science that takes a lot of time. If you could accelerate it, this could accelerate the entire process itself. And we already have some encouraging results here, seeing how this can actually accelerate the work on many, many cases. So really excited about this work of opportunity to help accelerate scientific discovery itself by using AI. Now, when we think about a lot of what we do, of course, is using generative AI. And when you think about some of the work that we're doing on the research side is to try and accelerate and make the generative AI more efficient. And make it more efficient also because its energy efficiency for that is obviously a huge concern to us, so we'd like to make that efficient. But also, if you make it more efficient, we can actually get more results on that. Here's one example out of many. In the work that we did, an algorithm called speculative decoding, we showed that we can actually get the same quality of inference by large language models using only half, between a factor of 2 and 13 of efficiency, both in terms of latency and in terms of energy efficiency and so forth. And in fact, built on that are hundreds of other works with various variations that actually show many other improvements that can be used across industry. Now, if you take this technique along with many other techniques across the entire stack of the generative AI, it turns out that we can actually have huge improvements in the efficiency of the processing units, which again translates to both ability to actually compute more with AI, as well as the ability to actually save energy on for the same computation that we're using it for. In fact, we just published a report quite recently showcasing these improvements and how we actually got into them, including many algorithmic techniques, system techniques, considerations for making data centers more effective, and so forth. Let me also touch about another direction that I think is going to unlock many new opportunities, which is quantum computing. As we know, quantum computing can actually solve problems that classical computers cannot actually do that. In fact, and we have a team actually working as part of Google Research on building a quantum computer, solving some of the problems, publishing quite a few papers in Nature and other places. And we're making good progress towards this milestone. In fact, last year we had these 2 significant milestones, one showcasing a problem, a benchmark problem that on a classical computer would take 10 septillion years. This is 10 with 25 zeros, where on a quantum computer it can be solved in under 5 minutes. Because quantum computing has a different paradigm of computing, which is not replacing classical computer on all problems, but on certain problems it can actually solve problems that are impossible to solve on a regular one. Another important milestone was actually showcasing that we can unlock error correction in a better way than we could do before. So again, once we do that, I'm sure there are going to be many problems that we already know quantum computing is going to help. But importantly, I'm pretty sure that there are going to be many other problems that are going to be unlocked and people are going to discover once quantum computers are going to be more widely used. Now, this is all done together with academics, with other companies, with startups, and so forth. But to me, the promise of AI is really that it's an amplifier of human ingenuity. If you think about co-scientists, if you think about others. But in order to do that, of course, an important aspect is improve education. AI can actually be transformative to education itself. I'm just highlighting this is one exciting opportunity for us is to actually make the entire next generation more savvy and use AI to actually provide better education in a more equitable way, but also provide a kind of skills for the next generation to help doing more of that. In fact, I was just visiting a high school in Ghana a few weeks ago, seeing how an application based on some of our models that were adapted for education enabled teachers to actually be order of magnitude more effective in providing assessments to students. And this is kind of just early testing of what can be done with that. If you go back to the co-scientist paradigm, if you think about the premise of AI to actually help us in what we're doing, of amplifying our work, I gave the examples on biomedical research. But think about the following. Even the likes of Edison. Edison had actually, he is obviously one of the, perhaps the most prolific inventor in history, and he had an invention factory. He did not do it on his own. He had all the other people working with him, helping him with the invention process. Just imagine that every person, every innovator could have their own invention factory of AI agents helping them. Much in the same way that with AI co-scientists, you don't need to be an established professor to have a lab of postdocs and grad students. In fact, every grad student and every postdoc have their own lab of AI scientists. And then, of course, we're going to raise the bar of what we expect from researchers. So this is about accelerating scientific discovery, it's accelerating innovation, it's accelerating invention. And the same paradigm applies to other aspects of life. In fact, I remember visiting Louvre, an exhibition of one of the 3 paintings that Leonardo brought from Italy to France. And what struck me in that exhibition was actually not the reconstructed picture, but the fact that they showed a dozen other pictures of drafts that were all done by his apprentices. I could not see the difference, but it was a good reminder that Leonardo, as much as genius as he was, he actually had apprentices. Now imagine that every person could have their own apprentices with AI actually helping them and amplifying their ingenuity. And you can apply it in so many different ways. In fact, one of the power of AI is that it actually can go through disciplines. It knows everything. It can actually bring together the ability to cross-pollinate disciplines. So really what you have in your disposal is not only an apprentice in art, an apprentice on a grad student in biomedical or an invention. In fact, AI can have agents that can help on all these topics and bring together and help connect the dots for whoever is using it. So this is one way of doing that. Now, in a way, Eric Schmidt and Kissinger and Mandel wrote a book, the book Genesis, about AI, and they actually gave the analogy of how you have a polymath in your pocket, which I think is a great way to think about it. Now, interestingly enough, when you do that, AI has a generation, and with AI agents, you can generate all these hypotheses and ideas, etc. At the end of the day, really what matters is to decide what really you care about. And this is something that is really, to me, one of the important functions of the human using the AI. In asking what do I want to solve for, what do I want to build? On the creative world, what is good? In fact, one of my favorite quotes is of Duke Ellington, which said, "If it sounds good, it is good." And this is pretty deep if you think about it, because this actually touches on the fact that actually there's no right definition of what's a good music. You need to decide that it's good. I mean, one of the interpretations. That's my interpretation. And this is actually one of the more important questions. With AI that can actually generate so many hypotheses, so many solutions, so many ways to actually solve problems, one of the more important things that actually we need to do when we use it is to make sure that we're asking the right questions, we're forming the right functions, we have the right objectives, and of course, we're putting it with the right values so that the AI systems are doing what it needs to do in order to serve humanity in the right way. So I think great opportunities ahead, really excited about it, and I hope you are as much as I do. And thank you again.